Hello class, in this video I will be doing a second example on how to find the remaining trig values given only one trig value and the quadrant that theta lies in. Let's begin. So in this example we're given that the secant of theta is equal to negative square root of 5 divided by 2, and theta is in quadrant 3. So I'm going to go ahead and draw theta to be in quadrant 3. Okay, so we have secant of theta is equal to negative square root of 5 divided by 2. And secant of theta is the reciprocal of cosine, so the numerator is going to be your hypotenuse, which is going to be r, and the denominator is going to be the adjacent side, which is going to be a. Okay? And since your r cannot be negative, I'm going to move the negative sign down to the denominator. Okay, so I'm going to put a point here. We know that the hypotenuse r is going to be the square root of 5. And we want a to be negative 2. And notice that it's appropriate that a is negative because we are traveling to the left and then down. So notice that our solution b is also going to be negative. How do we find b? Well, we have to apply the Pythagorean theorem. So we know that negative 2 squared plus b squared has to equal the square root of 5 squared. And I'm going to simplify this. And since to get to the coordinate that the terminal side passes through, you have to go left then down, we are only going to consider the negative value. So b is equal to negative 1. So now we can go ahead and figure out the rest of our trig functions. Starting with cosine. Cosine is the reciprocal of secant, so that would be negative 2 divided by the square root of 5. Sine of theta is going to be equal to negative 1 divided by the square root of 5. Tangent of theta will equal positive or negative 1 divided by negative 2, which happens to be a positive 1/2. Cosecant of theta is the reciprocal of sine, so that would be negative square root of 5. And the cotangent of theta is the reciprocal of tangent, so that would be positive 2. Okay, notice all of the trig functions that are supposed to be negative are negative. So cosecant's negative, sine's negative, cosine's negative, and the secant is negative. And the two trig functions that are supposed to be positive are indeed positive. Tangent's positive, and so is cotangent.